We are at the final stage of our Mobile3DTV project, and now we are testing the end-to-end system, which consists of encoded video, 3D video, encoded by multi-view coding, and the videos are stored in our playout server, and then they are encapsulated and broadcast over the full-size DVB-8 channel. The signal covers the campus of Tampere University of Technology, and at the same time users are being testing our mobile prototype, our handheld device, which is capable of receiving and decoding the multi-view streams and then playing on an autostereoscopic display. At the receiver side, we have also some improvements of the visual quality. Especially, we have designed anti-aliasing filters for the display based on our methodology for measuring optical characteristics of autostereoscopic displays, which we extended for the case of mobile autostereoscopic displays. The tests are running fine. We have test persons who are supposed to tell their opinion about the service and the system as a whole, also the perceived experience quality of 3D video content.
Work package 2 of the Mobile3DTV project, we especially looked into coding methods for stereo video content for mobile services. Prior to that, a large database of stereo video content was assembled with special requirements to mobile services like restricted resolution, etc. So one of the major tasks here was the coding of this in conjunction with the formats itself. So we looked into coding approaches like single view coding, which is again quite generally applicable to all these formats, where each of the two views is coded independently. Then we also looked into multi-view video coding, where for the conventional stereo video format, both views are jointly coded, so you exploit not just temporal dependencies within a sequence, but also dependencies between the two views, and as a result you gain higher compression efficiency in comparison to single view coding. The mixed resolution also gives a bit higher compression in single view coding, and for the video plus depth format there is a standard, it's called MPEG-C Part 3, where both data are still coded using single view coding. However, they are put into a container format telling the decoder that the first part of the bit stream belongs to color and the second belongs to depth. All these optimized coding results were then given to WP4.
In work package 3, we are dealing with the error-resistant transmission of encoded 3D video over DVB-8 channel. And for this purpose, we have done some experiments on the parameters of the DVB-8 standard at the link layer. We have this error correction capability in the link layer as the standard states, and we try to find the optimal parameters of the link layer in regard to robustness against channel errors. And we are trying to optimize this parameter together with the encoded video with its bitstream quality, because distortion is also existed in the encoding stage of the video. So we somehow jointly try to optimize these two parameters.
In work package 4, we were responsible for the subjective testing, and we tested all the system components from the beginning of the production chain, which means content-related issues and encoding-related issues, but also issues in transmission and also on the display side. And within our evaluation, we followed a user-centered quality of experience approach that was applied until the whole prototype was ready. And this user-centered quality of experience approach means that we use those potential users as quality evaluators within our work, that we studied all the necessary system characteristics, which means that we also included popular content for Mobile3DTV, as well as those critical system components. And those things were elicited at the beginning of the project, where we did a large user study on the user requirements for the system under development. And in addition, the work was extended with the development of 2 new research methodologies that are now included in our user-centered quality of experience evaluation framework. And the one method is an extension of laboratory studies into field context situations, so that we are able to evaluate quality also in the potential context of use. And within this method, the result is an evaluation in such quasi-experimental settings, where we conducted studies, for example, in buses or in cafes, in contexts that are popular for Mobile3DTV. A second method is called open profiling of quality, and this extends the currently existing methods with the possibility that our test participants were allowed to develop their own quality factors. And with this open profiling of quality, we target an additional understanding of the interpretation of quality of individual users.
I think it was a good experience to use this kind of device. At the beginning, maybe it felt some kind of strange because I have never used handheld device that was and have this 3D experience, but it was quite nice to just be relaxed and see some of the visual content and that has this extra feature.
The overall quality was quite good, but I just noticed some, shadowing. When you have a, for example, head of the skydiver, there was another head, just between him and some another guy, and that head was less visible, but anyway it was visible. I don't know why, maybe because of the frequency. But the quality was good also in animation and in the sport, and I think the best was in the animation. Yeah.
Okay.
At work page 6 we're developing the prototype terminal device, and this device, so it has out-stereoscopic display and DVB-H receiver, so we receive DVB-H broadcast and code H264 multi-field and render it on the display.
Yeah.